All right, so let's attempt a slightly more difficult natural deduction proof. Okay, the previous tutorial, the proof was not long at all. It was 2 steps, right? And we were able to demonstrate validity in a very quickly and efficient way. Okay, now most of the proofs that we're going to see aren't that simple. Okay, they're going to utilize one to maybe all of the argument forms here. Okay, now looking at the argument that's given here, we have 4 premises and our conclusion. Okay, what I like to start with when I begin to think about ways of starting the proof is I look at the conclusion. Our conclusion in this argument is if E then M. Okay, and I just like to look through the premises to see where those letters are, independent of the symbols. Okay, so I see E as the antecedent, right, in this conditional, which is part of a broader conditional, right? So here, 1, A is our antecedent, then if E, then not F, that's our consequent in the bigger conditional there. Okay, so I see the E there, and I also see the M as the consequent in this conditional, okay, which is actually one disjunct in this disjunction, okay? It's very important when we're starting the proofs to not only see where the letter variables are, but distinguish the symbols, okay? A common mistake that I've made is confusing a modus ponens or a modus tollens inference with the disjunctive syllogism here, right? Notice that in the disjunctive syllogism, this is our only inference that utilizes the disjunction, the wedge, right? So you really need to be alert and paying attention to the differences. Okay, so let's get our proof going then. All right, so it looks like we can start with at least 2 different inferences here. Okay, so I see that with 1 and 3, there is a modus ponens inference that can be done, right? I also see 2 and 4, there's a disjunctive syllogism that can be done using those premises. But I'll just start with 1 and 3, okay? So looking at the modus ponens, right? So anytime we have the antecedent, right, all by itself, we can affirm the antecedent is the case in the conditional, right? So if A, then if E, then not F. A is the case, so if E, then not F. Okay, so the consequent follows, given that A is the case in 3. And we get that from 1 and 3 modus ponens. All right. Now, if you decided to start the proof with 2 and 4, totally appropriate, and that's just one of the choices that you can make when completing these. I'm choosing it to do second, just because it seems to be more of a natural progression in the proof. Okay, now looking at 2, again, it is a disjunction, right? So according to the disjunctive syllogism, whenever we can eliminate one of the disjuncts, the other disjunct follows. Okay, and we can do that with either disjunct. In 2 here, we're going to use 4 to eliminate H. 4 tells us H is not the case. Okay, so whenever we eliminate one of the disjuncts, the other disjunct follows. Okay, so if not F, then N. Okay, and we get that from 2 and 4 via a disjunctive syllogism. Okay, so this whole thing follows. One thing to point out as an aside with the disjunctive syllogism, it's really important that you maintain whatever truth values are within the disjunct, right? Whether it be a single letter variable with a negation, or in this case, the disjunct is a conditional, okay? We are not tinkering with the truth values of the disjunct at all, right? All we are doing is saying one of the disjuncts isn't the case, so whatever the other one is, it follows naturally, okay, according to the disjunctive syllogism. All right, now it looks like we are ready for a final step here, right? And looking at the conclusion once more, I see that it's a conditional, right? So whenever you have a conditional as a conclusion, chances are, not 100% of the time, but with all likelihood, you're going to need to use a hypothetical syllogism to get whatever the conclusion is, if it's a conditional, right? So looking at the proof, I see that we can utilize the hypothetical syllogism argument form here, given that we have a common letter variable with the same truth value. So in a hypothetical syllogism, all we do is we link two of the different letter variables, one as an antecedent, one as a consequent, through a common letter variable, which is also an antecedent and a consequent. Okay, so Q here is the linking letter variable. So we get it through the transitive principle, right? We all remember that. If A then B, B then C, if A then B. That's all that's going on in the hypothetical syllogism, remember. Okay, so if we were to just read 5 and 6, if E then not F. If not F, then M. Okay, so according to the hypothetical syllogism, we get 4, 7, if E then M, from 5 and 6 using the hypothetical syllogism. Okay, again, not F, common letter variable with the same truth value. So we are able to link that antecedent in 5 with that consequent in 6. Okay, so what looks like a somewhat complex or tricky proof, we completed in 3 steps, using 3 different argument forms here. So don't be scared off, when you're looking at this, thinking, oh, wow, there's so many symbols, and I'm, wondering how on earth I could, prove the argument's validity in an efficient way. Okay, here we've done it fairly quickly. Okay, the next video, we're going to see even slightly more complex deduction proof, and we'll make quick work of it using the 4 valid inferences.